This is Math 105, Section 3.1a. We're going to start by talking about polynomial functions. We talked about this a little bit already. So polynomial function of degree n looks like this. We might use a capital P to define that. A to the n times x to the n plus a sub n minus 1, x to the n minus 1. Sorry, a sub n, not a to the n. Plus a to the 1 x plus a to the 0, and we have a bunch in between. Okay, so what this notation means is this. Let's say n is 3. That would be x cubed, and we would call this a3, and that would be the coefficient of the x cubed term. So just that this subscript on the a corresponds to the exponent. So these are the same. If this is a 3, this is a 3. And that means whatever this number is, we call it a3 as a label. So let's say this is x squared. This would be a sub 2, whatever number it is. It could be, 7 or 6 or whatever. Okay, and then all the way down. So basically what we're doing is we're going from higher power of x down, and we say n is an integer, positive integer. So this, let's say this is a 5, this could be a 4, 3, 2, 1, 0, etc. So we're going to go in descending order on powers of x. These numbers are always going to be positive integers. So we won't have a negative here, we won't have a half or anything like that. We'll always be positive integers. Okay. Okay, so the degree is the highest power of x that you see. Okay, some have degree 0, so we could just have like a number like p of x equals 2. That would be a degree of 0. That means we have x to the 0. That's the highest power of x. Okay, remember that's a flat line. Okay, and then let's say we have a linear function which might look like this, like 3x plus 2 or something like that, where the a1 would be 3, the a0 would be 2. That would have a degree of 1. The highest power of x is 1. Okay, so let's look at a quadratic function first. So a quadratic function is a polynomial of degree 2. Okay, so the form is going to be like this. F of x equals ax squared plus bx plus c, where a is the x squared coefficient, the number part, b is the x coefficient, and c is the number part by itself. Okay. And b and c can be 0, but a has to be non-zero because we have to have that x squared term to be a quadratic. Okay, so let's look at the most basic quadratic. If we have a equals 1 and b and c equals 0 in this form, we just have f of x equals x squared, which is that parabola, that centered, has a vertex at 0, 0, and it goes up. We know what that one looks like. So that's kind of the most basic quadratic. So now in order to graph these quadratics, we want to get these quadratics in standard form. And this is what standard form looks like. F of x equals a times x minus h squared plus k. Okay. Now this is kind of similar to the form of the circle where we have h and k, but here h and k is the vertex of the parabola. Okay, and a is that, remember, a is the coefficient of x squared, so it's the same a that you have here. And the parabola opens upward if a is positive, and it opens downward if a is negative. Okay, so this is a case where a is positive. We have this one opening up, and then here if a is negative, this one opens down. So that determines that a coefficient, the x squared coefficient determines whether it opens up, positive, or if it's negative, it opens down. Okay, and the vertex will be that hk. Okay, so we'll show how we do that, and we're going to complete the square to do that. Okay, so let's look at an example. Let's say we have f of x equals 2x squared minus 12x plus 23. Here our a is 2, so we know it's going to open up, right? So we want to express in standard form, and then sketch the graph. Okay, so here's the trick for completing the square. That's what we want to do. Look at the x squared and the x term. Don't worry about the 23. Just kind of push it over to the side, or just leave it over there. Okay, and we want to factor out the a. So if our a is not 1, we want to factor out the a out of these two. So we're going to factor out 2 out of this and 2 out of that. Okay, so we take 2 out of the x squared minus 6x. Okay, now you see here we've got x squared minus 6x. We can make it a perfect square by adding a minus 3 squared, right, or a 9 here, okay? So what we did was we really added an 18, a 2 times 9, right, because we have a 2 on the outside. So we've got to subtract it out again. Now we're working on the same side of the equation. So when you're working on the same side, if you add something to it, you also have to subtract it out because it's not supposed to be there, okay? So this makes it a perfect square, right? And then we have minus 18. So 23 minus 18 is 5. And then we have 2. This thing is x minus 3 squared. Okay. So we see our a is 2. Our h is 3. and our k is 5. Okay, so the a being 2 means we stretch it by a factor of 2. Remember, that's a stretching thing. We shift it to the right 3 units, and then we move it upward 5 units. So let me write that parabola out again. So we see this is y equals 2 times x minus 3 squared plus 5. That's what we got by completing the square. So we see our first step, well, we could shift first, but we could stretch first. You know, we could go y, looks like they're shifting it first. So first they go to y, from y equals x squared to y equals x minus 3 squared. So that shifts it 3 to the right. Okay. Then we go y to equals 2 times x minus 3 squared. So that's a stretch. I'll put SD for stretch. And then finally our last step is just to add 5, which means we move it up 5. Okay, so 2 times x minus 3 squared plus 5. That's up 5. Okay, so stretch 3 right, up 5 there. Okay, so these are our steps here. Okay, kind of showing, you know, start with x squared, then we make it x minus 3 squared, go 3 to the right, then we do 2 times x minus 3 squared, which means we stretch it, and then we add 5, which means we go up 5. Okay, so those are the steps there. Okay, now the vertex is where, if you know, here our vertex is 0, 0, so if we go 3 to the right and up 5 on the graph, our vertex is going to become 3, 5. So the h here is 3 and the k is 5. Okay, so we can pick out the vertex there. Okay. So this is what our graph looks like. You know, we started with the x squared, we shifted it 3, then stretched it, and then moved it up 5. Here, 5 scales, 5 is here. So our vertex is 3, 5. There's our h, and there's our k. Remember, this is our standard form is y equals a times x minus h squared plus k. So we can see that our vertex is 3, 5. Okay, and there it is. Okay. And then we have to find our y-intercept by setting x equal to 0. So when we set x equal to 0, we get 2 times 9 is 18 plus 5 is 23. Okay, that's easy to find. Okay. Okay, to find the minimum or maximum value of a quadratic function is pretty easy. You just need to find the vertex. Okay, so if it opens up, the vertex is a minimum, and it opens down, the vertex is a maximum. So, so if it opens up, a is greater than 0, the minimum value of f is k of the vertex. F of h equals k. And if it opens down, a is less than 0, then the maximum value is the vertex, or f of h equals k. Remember, h is the x of the vertex, and k is the y of the vertex. So f of h equals k. That's in this case, that's the minimum value there, is the k. And then if the a is negative, the maximum value is the k. So we just have to find the y value, the vertex, in each case to find the minimum or maximum. Okay. Okay, let's look at another example. Here we have f of x equals 5x squared minus 30x plus 49. Our a is 5, so it's going to open up. Let's express in standard form, sketch the graph, and find the minimum value this time. Okay, again, so to complete the square, we're going to focus on these first two terms, the x squared and the x term, and factor out that a, that 5. So we're going to factor the 5 out of the x squared and also out of the 30x. So we get 5 times x squared minus 6x. Keep the 49 off to the side. Okay. Now we make this a perfect square by adding minus 3 squared. So we're going to add 9 there. Okay. So we really added 5 times 9 because we have a 5 on the outside here. So we have to take it out again. Okay, so we take out 5 times 9. Okay, and then keep the 49 there. Okay, so 49 minus 45 would give us 4, and then we have 5, and this is x minus 3 squared. So here our h is 3, and our k is 4, and our a is 5. So our vertex will be 3, 4. And we're going to stretch it by a factor of 5 when we, after we shift 3 to the right and then move it up 4. Okay, so here we see here's our completed square form. Vertex at 3, 4, h is 3, k is 4. It opens upward because a is 5. It crosses the y-axis at 49 because when x is 0, we have 5 times 9 is 45, plus 4 is 49. Okay. And since the coefficient of the x squared is positive, f has a minimum value, and the minimum value is f of 3 equals 4. So the minimum value of the function is 4. Okay. Remember, the value of the function is the y. Okay, so the minimum value of that function is 4. So it's just the y of the vertex. Okay, let's look at one with a negative a. Here our a is minus 1. So we have f of x equals minus x squared plus x plus 2. Express in standard form, sketch the graph and find the maximum. Remember, it's going to open down, so that vertex will be a maximum. Now we have to have a 1 on the x squared to complete the square, so we're going to factor out that -1 or negative. Okay, so we're going to factor out, again, the x squared and the x term. So a negative, and then x squared minus x in the parentheses, because this is a plus x there. Okay, so we have to take half of this coefficient, right, and square it. Remember, our coefficient here is 1, so we take, or -1. So if we take -1 times divided by 2, we get -1/2, and we square it, we get 1/4. Okay, so we're going to add a fourth there to get a perfect square. And then what we did was we really added a -1 times 1/4, so we're going to subtract it out there. See, so we're going to subtract a -1 times 1/4 because we added a -1 times 1/4 here. Okay, remember our 2 sits out there. Okay, so this becomes x minus 1/2 squared is a perfect square. Remember, the minus is on the outside. Okay, and then 2 minus a minus 1/4 is 2 plus 1/4, which is 9/4. Okay, so here our h is, so there's our perfect square. Our h is a half, our k is 9/4, and we have a negative in front, which means it opens down. Okay, so our vertex would be 1/2 9/4. Okay, so we see from the standard form, we see that the graph is a parabola that opens downward, has vertex 1/2 9/4. Okay, so find the intercepts. So when x is 0, y is 2. Okay, and that's easy to see. Okay. To find the x-intercepts, we have to set f of x equals 0. So we have minus x squared plus x plus 2 equals 0. And then you can change the sign of both sides, multiply both sides by -1, so we don't have a negative here. And that gives us x squared minus x minus 2 equals 0. Okay. Change the sign of everything on this side, and 0 just stays 0. Okay, and now we factor. We're trying to find out where it crosses the x-axis, right? So we're setting, so we want to see, and we get x minus 2 times x plus 1 equals 0. That gives us x equals 2 and x equals -1. Those are our x-intercepts. We already got the y-intercept of 2. We got the vertex. We don't need to plot any other points. We got a pretty good idea what this graph looks like. It opens down, right? Okay. So there's our parabola. Remember, arrows here. Okay. And then finally, our maximum value is just the y of the vertex. So the maximum value is f of 1/2. That's the x of the vertex, is 9/4. So that's the maximum value is 2 1/4 or 9/4 of that function. Okay, so the standard form that a times x minus h squared plus k helps us to sketch the graph, as well as find its maximum or minimum. Okay, if we're interested only in finding the maximum or minimum, we don't have to graph that. We don't have to get it in the standard form. Okay, we can actually find a formula which is obtained by completing the square for the general quadratic. Okay, so there's our general quadratic. Okay, I'm not going to ask you to show me this on a test or anything, but here's how we complete the square. We would take our x squared plus ax squared plus bx and factor out an a because we want a 1 on the x squared. So when we do that, we're going to have b over a times x. And then once you factor the a out, to make this a perfect square, we're going to take half of that b over a, the x coefficient, and square it. So that's b over 2a. And when you square b over 2a, you get b squared over 4a squared. So that's where that comes from here. And then our c is still out here. And then what we really did was add an a times b squared over 4a squared. So we have to subtract it back out here. Okay, so this is a perfect square. This is x plus b over 2a. Remember, half of this coefficient squared. Plus c, and this is minus 4b, or minus b squared over 4a. Because one of the a's cancels out here. Okay, so this is what we end up with. But the important thing is the h. Okay, what we're looking at is the x-coordinate of our vertex. So that's really all we care about. So our h here is not b over 2a, but our h is minus b over 2a. Okay, and that is the x of your vertex. Okay, and that's called our vertex formula. Okay, so that's the key here, is that we notice that our h here is minus b over 2a, okay, because it should be x minus h. Okay, so that's all we really care about as far as doing this. But I'm not going to ask you to complete the square on this. I just want you to see where it comes from, how we actually get that vertex, the x of the vertex. The y of the vertex is going to be here, but we won't worry about that because you can find the y by plugging in. Okay, so we get that h equals minus b over 2a. That's the x of our vertex. So that's how we get our vertex formula, which is x equals minus b over 2a. Okay, so that's true for any parabola. if you plug in, where your a is your x squared coefficient, your b is your x coefficient, and your c is the number part, just plug in minus b over 2a and you get the x of your vertex. Okay, so to find the minimum value of a function, when your a is positive, remember your vertex is the bottom of the parabola because it opens up, the minimum value is just the y value, or f of that x of the vertex. So we find the y of the vertex, so f of minus b over 2a. Okay. And then if your a is negative, that means the parabola opens down. The maximum value of the function is the y of the vertex. So we just take f of that x value at the vertex, minus b over 2a. Okay. So the important thing is that vertex formula is just x equals minus b over 2a. Think of it this way. Remember our quadratic formula. Right? X equals negative b plus or minus square root of b squared minus 4ac over 2a. Well, scratch out the square root part. Okay? And what do you get? You just get that minus b over 2a. So you can think of it as a quadratic formula without the discriminant, right? Where the discriminant is 0. Okay? So that's where the vertex formula you can kind of think of that's kind of where it comes from in a way. Okay, so let's find the minimum or maximum value of each of these quadratics. F of x equals x squared plus 4x, and g of x equals minus 2x squared plus 4x minus 5. This one opens up, so the minimum will be a vertex. This one opens down, so the maximum will be a vertex. Okay, so looking at that first one, f of x equals x squared plus 4x. Our a is 1, okay, and our b is 4. We don't care about the c. So the x of our vertex is minus b over 2a, so that would be minus 4 over 2 times 1. Which is minus 4 over 2, which is minus 2. Since a is greater than 0, the function has a minimum value at the vertex because the parabola opens up. So our vertex is going to be a minimum. Okay. So we plug in the minus 2 into our function. Okay. And we get minus 2 squared plus 4 times minus 2, which is 4 minus 8, which is a minus 4. So that is the minimum value of the function, is that minus 4. Okay. It's always the y value when we talk about the value of the function. Okay, and the second one, part B, is g of x equals minus 2x squared plus 4x minus 5, that quadratic. So our a is minus 2, our b is 4, our c is minus 5. So x equals minus b over 2a, so it's minus 4 over 2 times the minus 2, okay, which is minus 4 over minus 4, which is just 1. So that's the x value of the vertex. Since a is less than 0, our parabola opens down, which means the vertex is a maximum. Okay, so we plug in 1 into our function that we got from taking x equals minus b over 2a, and we get minus 2 times 1 squared plus 4 times 1 minus 5. So this is minus 2 plus 4 is 6 minus 2 times 1 is minus 2 times 1 squared is minus 2 plus 4 is 2. Minus 5 is minus 3. So that would be the maximum value of our function, that minus 3. Okay, the last thing we'll talk about in this section is modeling with quadratic functions. We're going to look at real-world problems, phenomena that are modeled by quadratic functions. So let's look at the mileage function. Most cars get their best mileage when they're doing a relatively moderate speed. So not fast speed or not super slow, so something in between. So let capital M be our mileage for a certain car, and S will be the speed. Okay, so S is like our X and M is like our Y. Okay, so this is our quadratic model. M of S equals minus 1/28 S squared plus 3S minus 31. Now we notice that parabola will open down, right, because the A is negative. So we're going to find the vertex to find the maximum M, the maximum mileage. Okay. And we say here our S is between 15 and 70. So we're not looking at speeds below 15. We're not looking at speeds above 70. So where's the car? What is the car's best gas mileage? What speed is it attained? Okay. So we're going to find the vertex of that. So just remember, this is our mileage function. M of S equals minus 1/28 S squared plus 3S minus 31. So S, we're using S instead of X. We're finding the vertex equals minus B over 2A. So that would be here our A is 1 minus 1/28. B is 3, and our C is minus 31. So minus B over 2A would be minus 3 over 2 times a minus 1 over 28. So that would be minus 1/14 in the denominator. So 3 divided by minus 1/14 is minus 42. We have a negative in front, so that gives us a plus 42. We do that. Okay. So 42, this is the miles per hour. That's the speed where we get the best mileage. It doesn't tell us what the best mileage is, it just tells us the speed where that occurs. So that's like our x value, okay? And then, so you're going to get your optimal mileage at 42 miles per hour, and here's what your mileage is. So we're going to plug in 42 into our quadratic. So minus 128 times 42 squared, plus 3 times 42, minus 31, and that gives us 32 miles per gallon. Okay, so this would be our optimal mileage, and that occurs when you're averaging 42 miles per hour. Okay, so the car's best mileage, gas mileage is 32 miles per gallon when it is traveling at 42 miles per hour. Okay, we'll look at some more models in class, complete the square and some of the things, but we should be familiar with completing the square because we did this for circles, right? It's just now that we're doing it in one variable and we're kind of working on one side of the equation. So, okay.